Myself, Dr. Reddy Jadav, working as a assistant professor in CSC department, Laxman Reddy Institute of Technology and Management, Dundigal. In the previous video, I was explained that automata theory. What are the basic concept? What are the basic concept and what are the terminologies are used in that automata theory? Now, in this video, I am going to discuss about finite automata. What is the finite automata? Finite automata consists of a finite memory. It's called as the input tape. Because of the input tape can be divided into the number of cells and finite non-empty set of states and input alphabets that is called as a sigma and read head only and transition function that is called as a delta functions and initial state mean whatever it will be start from q0 and final state set of final state. But in this video the model of finite automata is given whatever it is a input tape, this the reading head and finite control. But input tape, this input tape can be divided into the number of cells. Each cell can store that only one symbol at a time, like this A, B, C, or D. But if the leftmost cell is there, this indicates that beginning of the input tape. Dollar prompt is there, that is the rightmost cell. That is the rightmost cell that will be indicates that end of the input tape. But here that finite control will be decide that it moving from which state to which state. The reading head is read that single symbol from the input tape only. But it will be moving, either it will be moving left to right for reading purpose only. Or whatever it can be moving right to left also. But in this one, here that we cannot write, either from the left to right or right to left. That is the concept of finite automata. So, types of finite automata. There are two types of finite automata. So, whatever one is deterministic finite automata, that is called as a DFA. Second one is the non-deterministic finite automata, then is called as a NFA, or it is called as NDFA. First of all, I want to explain that this deterministic finite automata with that few examples. In DFA, for each input symbol, one can determine the state to which the machine will move. Means it moving from that one state to another state. It is called as a deterministic automata. The machine is called as deterministic, here a finite machine or deterministic finite automata. Main agenda of the deterministic finite automata, it will be moving from one state to exactly one state. How? Delta of, that is a delta is a transition function, delta of q naught comma a, it goes to that q1 only. Q naught is the current state, with that a, it is the current input, it goes to the next state only. Which next state? Q1 only. Q naught with the a, mean transition function moving from current state Q naught with that current input A goes to that Q1 only. Q1 only. That is the deterministic DFA, deterministic finite automata. So what is the formal definition of DFA? DFA can be represented by 5 tuples. This is the most important. One is Q, second one is sigma and delta and Q naught and F. Every transition diagram in the finite automata, it must have a Q, sigma, delta, Q naught and F. Sir, what is the Q? Q is the set of states. So for example, I want to give that one small example. Here the transition diagram Q naught. Q naught with that input A goes to that Q1. And Q1 with B goes to that Q2. Here that Q2. Q2 is a final state. Q2 is a final state. And it is a Q pi, it is a hang state. Mean every state has the two edges. It is a B. And then it is a. Then it here that itself AB. I want to take. How many state Q is the set of state mean how many state Q0, Q1, here the Q0, Q1 and Q2. But QF is the hang state or dead state. That is the set of state. Sigma. Sigma is here the input alphabet. As per as this diagram. What are the input alphabet? A and B. And what is the transition functions? Q into sigma mean Q, it is the current state with the current input, goes to that next state. Mean it there is a only one path from current state to next state, or it generates that only one state, only one next state. That is that. Here a Q naught, current delta of Q naught comma A. It goes to that Q1. There is a only one path from current state to the next state. That is a Q. Q into sigma tends to the Q. And Q naught, here the Q naught is the initial state. Only single circle. That is belongs to that Q. And here that, which one is that, if any one of the state having the double circle, then that circle is called as a final circle, that is the Q2. And Q naught is that initial state, remembering. So graphical representation of DFA. DFA is represented by digraph is called as a state diagram. All of you know that. The vertices represent the state. Vertices mean it is a node. Vertices, this one is represented as state. Arcs labeled with that input alphabet, that is that it is a arc with that labeled input alphabet Q1 to Q2. Here a label with that B, that is the alpha input. Initial state is denoted by empty single incoming arc. This is the Q naught is that initial state. And final state, every NFA and DFA must have a final state. The final state is indicated by double circle. As per this transition diagram, Q2 is a final circle because of here the final state, because of it is having that double circle. This is the concept of DFA. See that I want to give that example. In this diagram, DFA graphical representations, there are three states are there. A, B, C. There are three states. With that input alphabet. What are the input alphabet? Here that 0, comma A, 1. And Q naught. Here that A is it is the initial state. And double circles, which state having the double circle? Yes, it is a C. It is a final state. Final state. What I said in the DFA, every state must have a two edges. See that A is a one state. Here the itself only. Here Q A with 0, A only. A with 1, so it goes to that B. Here that B with 1, it goes to that A. And B with 0, yes, goes to that C. And C with 0 goes to that B. And C with 1 itself. As well as this transition diagram, every state has a two edges. See that transition table. By using with that transition function only. See that here the sigma, what are the input alphabet in this diagram? 0, comma 1. Present states. How many states are there? A, B, C. That's where written A, B, C. Row represented as a states, column represented as a input alphabet. In the state, it is a input of how many alphabet as per this transition diagram? 0, 1. A with whatever 0 and 1 input are. A with 0, it goes to that itself only. So that's why it is written the A. A with 1, it goes to that B. So whatever next state for input is 1. Present state is the B. B with 0. Here and B with 0. B with 0, it goes to the C. That's where written. B with 1. B with 1. Yes, it moves to that A. And C. Now you can take this C, whatever it is that initial state, it is a final state. C with 0, it goes to that B. So that's why written B. C with 1, itself only. So that's why written the C. This is the transition table for DFA. This is an example. Now, I want to give that one example on DFA. Design a DFA for sector strings starting with 0 over that alphabet 0, 1. See that our sigma is 0, 1. What is a set of strings? Set of string is called as a language. I want to write the language. Language is all the strings starting with 0. 0. 0. 0. And 0. 0, 1. Here the 0, 1, 0. 0, 1, 1. 0, 1, 1, 0. Whatever you can write. This is a language. So if you want to draw the transition diagram for that DFA, it is a language starting with 0, 0, 0, 0. Later that you can write with that any combination of zeros and ones. Depend on you. Now, in the language, minimum length of this string, minimum length is that 0. Here the minimum length of this string is 0 is 1. Minimum length is 1. That is called as a n equal to 1. How many states are required for draw the transition diagram? Here the n plus 1. N value is 1. 1 plus 1, 2. There are 2 states are required. 2 states are required for this draw the NFA. Because of minimum length of this string is 1. 1 plus 1, 2. That is the number of states. So that's why written number of states n plus 1 equal to here the 1 plus 1, 2. But how to draw this transition diagram for DFE? What I said, every state must have a 2 edges. See that here they given the diagram. It is a transition table. Q0 with 0, Q1, Q0 with 1, Q5, Q1 with 1, Q1 with 0, 1, Q1. Now see that how many states are required? 2 states. Q0 it is the initial state and here that Q1 is the final state. What is the minimum length of this string? 1. So whatever you can pass length is whatever you can write the here the long ways 0. Start with 0, 1. Start with 0. Then after 0, 1, 0. Start with 0, 1, 1. Start with 0, 1, 1, 0. And write. Minimum length of this string is 1. So that's why it was written that 2 states with the 0. Whether it is satisfied or not. First of all, you can take first 0. Q0 with 0, Q1. When it is reaches to the final state, the string should be accepted by the finite automata. In case I want to take 0, 1, sir, here the Q0 with 0, Q1. Q1 with 1 is there? No. Now can take that itself. It satisfies this one. Whatever you can take, W equal to 0, 1, 0. Q0 with 0. Q0 with 0, Q1. Q1 with 1, Q1 itself. Q1 with 0 is not available. So you can take that itself. Now, 0, 1, 1. W equal to 0, 1, 1. Q0 with 0 goes to that Q1. Q1 with 1, Q1. Q1 with 1, Q1. Then finally we reaches to that final state. Next, what I said, every state has a 2 edges. But Q1, Q0 with 0, then only one edge. What about the another edge? I want to take here the Q pi. This is the hang state or final state, nothing to use. Q0 with 0, Q0 with 0, Q1. Q1 with Q0 with 1, then like Q1 has the 2 edges, 1 and 0. This is the transition diagram for that DFA set of strings over that. Here the starting with the 0. Now, see the transition diagram as far as this. Here that transition table as far as that transition diagram. It is a state. Row represents the state. Here the state. Column represents the sigma. Sigma mean it is a input alphabet. How many states in this diagram? Q0 and Q1. No need to consider the Q pi because of it is a hang state or dead state. Hang state or dead state. Q0 with 0. Q0, current state is that Q0. Current input is that 0. It goes to that Q1. That's written. Q0 with 1. It is a Q pi. Nothing to use. And now Q1 with 0. Q1 with 0 itself only. That's why taken the Q1. Q1 with 0. Q1 with 1. It goes itself only Q1. Then you have one doubt. Sir, if you want to take any one of the string from the language, that will be accepted by finite automata or not. We want to check. What I said, when we have to reach to that final state, then that string should be accepted by finite automata. I want to take that any one of the string that is called as denoted by W 0, 1, 0, 1. Because of it must be start with 0. Then later you are going to write the combination of ones and zeros. Depend on you. Sir, whether this string is accepted by this finite automata or not. Now, delta is a transition functions. What is our string? 0, 1, 0. Sorry. Current state is, initial state is Q0. With that, string 0, 1, 0, 1. Q0 with 0. First of all, Q0 is the current state. Current input is that 0. Q0 with 0. Yes, Q1. See the transition table. Q0 with 0. Then Q1. 1, 0, 1. Now, Q1 with current state is the Q1. Q1 with the current input, 1. Q1 with the 1, Q1. 0, 1. Now, current state is the Q1. With that current input is that 0. Q1 with 0. Yes, it is a Q1. Q1 with 0. Q1. Q1, comma 1. Now we are going to check delta. Delta of Q1 with 1. Q1, current state is the Q1 with 1. Q1. Sir, before that what I said, if it is reaches to that final state, Q1 is the final state. When it is reaches to the final state, then the string is accepted by finite automata. As per this example, the string is accepted or not? Yes, this is accepted by finite automata. This is the first example. Then I want to explain one more example. Construct the DFA which accept all the strings over the alphabet. That is the input alphabet 0, 1. Start with 0, 1. Mean the string should be start with 0, 1. Now you can write the language. Here written that language. Initially start with 0, 1. 0, 1, 0 is possible. 0 in 1 it's possible. Here a 0, 1, 1, 1, 0 S is accepted. 0, 1. Then after you can write the combination of zeros and so on. In the language, it start with 0, 1. What is the minimum length of the string? 2. N equal to 2. Minimum length of the string is 2. But how many states are required for construct that transition diagram of DFE? Here that states are n plus 1. State are that n plus 1. What is the here the n value? 2. 2 plus 1, that is the 3. How many state for the transition diagram? 3 states. So that's why written. What is that? Here the string is W is 0, 1. Q0, Q1, Q2. There are three states taken. Now Q0 with 0, Q1. Q1 with 1 goes to the Q2. Mean Q2 is a final state. Before that, what I said, every state has a 2 edges. Every state has a 2 edges. Q0 with 0, it is the 1 edges. One more 1 is required. It goes to that hang state or a dead state. Q1 with 1. Q1 with 1. Q2. What about the 0? It goes to that Q pi, a hang state. And Q2, it is also required that 2 edges. Q2 with 0 and comma 1 itself only. Now, whether it is satisfied or not, you can take that any one of the string. First one is satisfied. 0, 1, 0. Q0 with 0. Q1. Q1 with 1. Q2. Q2 with 0 itself only. Then we reach at the final states. I want to take this string. Q0 with 0. Q1. Q1 with 1. Q2. Q2 with 1 itself Q2. Q2 with 1 itself Q2. Q2 with 0 Q2. Then finally we reach at the final state. Now you can take whether the string is accepted by finite automata or not. You can choose that any one of the string from the language. Any one of the string from the language. I want to take the string is 0, 1, 0, 1, 0, 1. Because of every string must be start with the 0, 1. Now, when we reaches to the final state, the string should be accepted by final automata. If it not reaches to the final state, the string rejected by finite automata. Remembering this point. Now, delta. What is the initial state? Q naught. Q naught. 0, 1, 0, 1, 0, 1. Now, Q0 with 0. But I am not taking that transition table. Directly, I want to explain through that transition diagram. Q0 with 0 goes to that Q1. 1, 0, 1, 0, 1. Next, Q1 with 1. Q1 with 1. Q1 with 1. Q1 current state with that current input symbol 1 goes to that Q2. What? Here that 0, 1, 0, 1. Current state is the Q2. Q2 with 0 itself. Then Q2. 1, 0, 1. Current state is the Q2. With the current input is the 1. Then itself only. Then we'll get that Q2. 0, 1 is there. Current state is the Q2. Q2 with that current input is 0. Then it is a Q2. Current state is the Q2. With that current input is the 1. So whatever Q2 with 1 itself Q2. Sir, Q2 is a final state or not? Yes, it is a final state. Before that, what I said, when it is reaches to the final state, that string W accepted by finite automata. Thank you, one and all.